Morning, good evening, good afternoon, dear students. So today's class, I want to dedicate it to someone that I don't know much. I cross paths. Her name is Cristel Morales Hernandez, and she's just a learning experience, a beautiful learning experience. Also, I want to talk to you about um, something that happened when I was working um, in one of the companies. I work as a network engineer. I will not say the company or the position, but this is what happened. I took a shortcut. I was overloaded with a lot of work, and I decided to clear some alarms that I was not supposed to clear, and I had to report those alarms to support teams, and that caused a problem because it was a production issue, and that happens only once, but it's just for you guys to be aware, and you have that knowledge that if those things happen in life, you have to be fully aware of not taking shortcuts, doing the job and your daily functions as best as possible, and report all possible issues and problems. So that's everything. I want to dedicate this class to this crystal person, and let's go with the lesson. Let's start. So today we have two labs. One is for NAT and the other one is for PAT. Let's just do it that way. Let's do the NAT version first, and then let's do the packet tracer lab. First, I have the lab pre-built, and this is IPv4 NAT. So network address translation NAT is the process where a network device, such as a Cisco router, assigns a public address to host devices inside a private network. The main reason we use NAT is because of public IPv4 address limitation, and we want to um, have more public IP addresses. So in a better way, so the administration of the IP addresses are in a best possible way, and we depend more on private IP addresses than public IP addresses. That's a little brief of the explanation that I have for the use of NAT for both IP addresses and private IP addresses. So let's start with the lesson today. Let me go ahead and open the Packet Tracer Lab. The first one that I'm going to work on is the NAT lab. So give me just a moment, please. I need to double click on this. And the first thing I will do is actually look for the website version. I just copy and paste this in Google. I just go to Google and I'm just going to copy and paste the name of the lab. In this case, it's 6.8.2 lab configure NAT for IPv4 answers. Maybe I'm missing something. Let me just double check something real quick. Yeah, I'm missing that parenthesis. I need to fix that. Give me just a moment, please. Please, please, please. So I almost have it ready. Okay, I was using more parentheses that I needed. Let me just fix it. Okay, let me just work on this. Perfect. Yeah. Mm, I think I might have something incorrect because I did the same twice. So let's just click and enter here, and I will work in a lab in a moment, but I need to fix something. One of the documents I need to change from PDF to Word, and the idea is that I did the incorrect file, so I need to fix that. So give me just a moment, and I will have it sorted in a bit. Um, okay, we don't need this for now. Let's just do it in the easiest possible way. So I'm going to delete one of the files because it's a repeated file, and I'm just going to work on this right now. So before I do that, I need to copy this lesson, erase the online version of this lesson, it's 39, And let me just work on that real quick. Perfect. I got it. So time to work. First thing I do, we open this topology and we don't really have a time limitation per se, but hopefully it is 100% full. So we don't have to worry about the results. It is already completed. But guys, do you know how we can reset this lab? Have you ever reset a lab? Let's see if we can do it. Mm, Usually if we add an email address, let me see if I can add an email address. I'm going to add my email address so it gets resetted. No, it doesn't, it's not letting me to reset it, the lab for some reason. That's strange. So let's not worry about it. If you just click in this, you can see the answers of the lab and follow along with me. So we are not going to worry about resetting the lab or not, just completing the lab. So let's work on it. First thing we do, all the cables and everything is plugged together successfully. Can we access the device particularly directly, or do we need to access console cable? No, we don't need console cable here. So we can access the device directly. First thing we do, we go to the router, R1. So let's go to router 1. And the first step is actually, I'm just going to type class. I'm going to type Cisco and then plus. I'm wondering if there's a way to reset this lab because I hadn't found it yet. But if there is a way, I will find it. I will figure it out. Reset activity and then okay. Great, great. So I just reset the activity. It looks like we have to plug all the cables together. Not a big deal. Should be easy. So we have to connect switch to switch is a crossover. So let's use a crossover cable here. And it is FA01, FA01. So let's go FA01, FA01. And let's see, the other one is the same thing, is a crossover, is gigabit 000, gigabit 000. Did I got that correct? Yeah, perfect. And then we have FA05 here, FA05 connected to gigabit 001. Perfect. What else do we need to do? We need to connect FA06 and FA018. So let's go with that. FA06 over here to PCA and then FA018 to PCB. Great. So the first thing we will do is to go to router 1 and now we will add that configuration that we need. We have to address the host name for the device. So that's the first thing we do. So let's work on this. Let me go ahead and work on it. Enable config T. And let's do it. Let's do it. Host name. Host name R1. Perfect. Now, next thing we do, we have to do a no IP domain lookup, domain touch lookup. Be careful with the grammar. That's it. No IP domain touch lookup. What else? What else? Oh, we have to do enable secret, still in router 1, class. We are adding the password for the privilege mode. In this case is class. We might have to encrypt it later, but we are not going to worry about it for now. Line 0, pass Cisco, then login. Then we have exit line PTY 04. Then we have password Cisco and then login. What else? Now we are going to encrypt it. So let's do service password encryption. And we have to add this banner mode. Let me just copy and paste it there. Let me just work on this. Let me paste it there. There you go. Now, let's work in the interface, and those IP addresses come from the addressing scheme that we have here. So let's go ahead and add those in a faster way. Yes, we can just copy this information, go to a notepad. Let me just work on it. Give me just a moment. And same process we have done so far before. We just copy and paste it and remove this. And we're going to add the IP address for gigabit 001, the IP address for gigabit 000, and that's it. And turning on those interfaces. So let me just paste it there. Great. Good job. Congratulations. So next thing we do, we have to configure a default route that goes from R2 to R1. And that's in the following way. We have to do an IP route 0.0.0.0.0, 0.0.0.0, all zeros, then 209.165.200.225. How do we know that is the correct to get to that specific destination from R2 to R1? Let's validate R1. What do we have in R1? R1, that is for gigabit 000, is actually 225 is actually the IP address to get from R2 to R1. Let me validate something. What does the instruction says? The default route from R2 to R1. It means all traffic is going to travel through this interface, the gigabit 000. That is the IP address of R2 actually. So it's getting from R2 through the exit interface, and that is this specific interface. That will be the exit interfaces. All traffic will travel there, and we will get from R2 to R1. And we are configuring zeros, 0, 0, 0, 0, and then 0, 0, 0, and 0, all zeros. And then the IP address, this one right there, this one is the IP address. We have 25, and what is the other one for this one? For our one, we have 230. So we have 230 and 225. Those are the two IP addresses that they will communicate each other. Okay. With that being said, let's go ahead and clear the board, and let's go ahead and continue building what we now know is easier to configure. We added the interfaces in R1. We added the default route, and that is actually I might have done a mistake here because I thought we were working in R2, but we are actually in R1. That is to get all traffic from R1 to the next hop IP address, which is the interface of R2, and it is that IP address. So I might have explained that incorrectly. Let me just explain it correctly there. That specific IP address that we are adding in the default route, which is 0.0.0.0, and then all zeros again, that is that one. Yes, but I was saying from R2 to R1. It's actually backwards. It's the opposite. The traffic will go, all traffic from R1 to R2. So that was my mistake. And then we have 0.0.0.0, and then the IP address 209.165.200.225. Now we got it right. Let's go ahead and clear the board. Let's go ahead and validate that we are adding that specific IP address. Let me just validate here. I added the interfaces. They are up. I am adding the default route that we were talking. It will travel all traffic from R1 to the next hop IP address, which is the interface connected to R2. What else are we missing here? Okay, we have to do an exit. We have to do a copy, running config, a startup config. And now we have to configure R2. it's pretty much the same deal. I'm going to copy the whole configuration for R2. I'm going to go to the notepad and I'm going to remove all the unnecessary information. So let me work on that. So we're adding the same. We're adding the privilege password. We're adding the line BTY password, the console password to have console access. We are doing the service password encryption, the banner mode, the interfaces. We are saving that configuration at the end. Look at this, copy running config as setup config. So I am almost done here. Please bear with me, be patient because I almost finished this. Okay, let me just copy this right there. Control Z, let's go to the other router. So let me just exit router 1 so we are not confused and let's go to R2. Let's go ahead and do an enable config T and let's paste it there. To WR just to validate. Maybe we are not saving the command was incomplete, so maybe that copy config command was incomplete at the moment, but we just added correctly, so not a big deal. Next thing, we have to go to switch 1. So let me just look for switch 1 and we can look it up there. Next thing we do, let's see if we have the whole configuration for switch 1. Do we have it at the end by any chance? So we can just add it there, just copy and paste it. Yes, let me just copy and paste the configuration for switch 1. What are we adding here? Let's do an enable. Let's do a config T and let me paste it there. We are adding the security, some of the interface range of IP addresses that are not necessary. We are going to shut down those. We are adding an administrative VLAN and a default gateway, and that's pretty much. Where do we get this information? So hopefully in the routing table, most of this information will be there. Let's just validate. And this is actually the default gateway IP address. So let me just paste the configuration and you can see here that we have the security part. Then we have the ports that we don't need. We are shutting down those. Then we have the administrative VLAN with the IP address, which is 1.11, and the default gateway is 1.1. So that's pretty much everything that we are configuring in the switch, the first switch. Next thing, let's clear the board. And let's go ahead and do the same process for the switch 2. Let me just copy the whole configuration. Let's go ahead and copy and paste it in a notepad. And let me go to look it up. I need to find the switch. After this, I click on yes. Let me do a 2WR. That's pretty much everything. Let me just do a show VLAN brief just to see something. I think we're just getting the basic VLAN information. We are not going too deep into VLAN's configuration per se. So interfaces are down there. So let me copy this in the switch 2. And hopefully we will be done with this lab in a couple of seconds here. Let me do an enable, a config T and paste it there. Okay, let's do a 2WR just to cover our box. That's pretty much everything. We got to 92%, but there are some issues that we are still there having at the moment. Maybe the troubleshooting commands and the overload commands. Yeah, we are missing those. So let's go ahead and do that part. And then at the end, if we don't get the result, we will go further into the lab. So let's go ahead and configure the PCs. I'm going to go to PCA and let me go to it. We have 192.168.1.2, 192 and 168.1.1, and that's it. Great. Let's go to PCB. Let's add the information on PCB. We have 192 and 168.1.3, 255, 255, 255.0, 192.168. That one. And let's see, we got it, 100%. Now, we want to go a little bit further and show you step by step how is the overload process and the path process. And this is the second part of the lab. We already have 100%, but we still want to run the commands. So let's go to R1 and let's go ahead and try to understand better. What are we going to add here? First thing, we are creating an access list to allow traffic for this network and subnet mask. So let me just copy and paste it there. After doing a config T, let me paste it there. I think I got incorrect information. Let me just paste it one more time. I got it. What else? Okay, we are doing a NAT pool of IP addresses with the net mask. So let me just work on it. Let me copy and paste that. Still working in R1. Perfect. Now we are adding the insight. We created the pool. We are adding the insight source for that specific ACL. Great. Now we need to apply the NAT correctly in those interfaces. So right now, the gigabit 001, that, where is it? Where is it in router 1? Where is it? One is the inside and the other one is the outside. Let's validate which one is the inside and which one is the outside. This one is the inside, go to the local area networks, and this one goes to router 2, is the outside. So let me just go there and explain to you in the graphic. So this one right here will be the outside, and this one right here will be the inside, which is our local area network, and that's why that one is the inside. Okay, let me go ahead and clear that, and let's go ahead and go to the configuration so we can do that part, which is essential and important. Okay, so we have the overload. Have we do that? No, we are in this section. We are applying the NAT correctly. Interface gigabit 001, IP NAT inside, enter. Interface gigabit 000, IP NAT outside, then enter. Now let's validate the following. Let's send a ping test to a loopback interface, which is 209.165.200.1. Let's go to PCB so we can do that test. It says that it shouldn't be working. It should be unsuccessful. Let's validate to see if it works or not. 209.165.200.1. Okay, so if the pin was unsuccessful, troubleshoot and correct the issues. So let's see if it works. Hopefully it will work on the second attempt, but if not, we will need to troubleshoot. That is because it is convergent, the network. So the second time we tried, it worked like a charm. Worked perfectly. Now we go to router 1. We execute the following. We do show. Let's do a WR just to save our configuration there. Show, then IP NAT translations. There you go. Look at all those. Those are representing. This one is the public IP address. This one is the inside local. This is a private IP address. This is another public IP address. Those are different ports. Let me go ahead and clear the board for a minute so I can expand on this so we can see it more clearly. Now I can explain it. Okay, so these are public IP addresses, which are the inside global. These are also public IP addresses, which are the outside local. And these are private IP addresses, which are the inside local. So we have public over here. We have public over here. We have private over here, and then we have public IP addresses. So we have the inside global over there, the inside local, then we have the outside local and the outside global. And these are different sockets or ports to which these specific IP addresses are connecting to. So this inside global converges to the inside local, and then the inside local, then that's pretty much the first conversion. Then we have the other conversion where the outside local converge to the outside global. That's pretty much what NAT does. It changes, in this case, private IP addresses to public IP addresses and public IP addresses to private IP addresses. That's pretty much what it does. Okay, let's run the following command. To IP NAT translation, what is the inside local address for the PCB translated? Let's validate that. And in fact is 209.165.200.226. That is the inside global. That is the type of NAT address that we're working. So let's do the same process for PCB. Let's work on PCA. And we are going to do command prompt. Let's do a ping connectivity test to 209.165.201. Look at that, working perfectly. Then we have to go to R1 and run the exact same command. And we see a little bit of less information, but in this case, it's pretty much the same inside global IP address. We see the ports, we see the information. It's pretty much the same one that we're getting when we're trying to reach one. Let's see, let's validate something. Are we doing a ping test to 201? Yeah. 209.165.200.1. 200.1. That is the one that we are doing the ping connectivity test. And this is the translation. Now we have to do something similar. Notice that in the previous table, PCB is still there. So from S1, it means we have to go to the switch 1 and do the following test. We have to ping the loopback. Let's do a ping test here. 209.165.200.1. Let's wait for a moment and hopefully it will be work the second time. 100%. Let's do a Choi Piana translation one more time with the up error, and you can see it's pretty much the same. It's just some of the port or socket are changing basically. So it's pretty much the same. We can see that. So the total of translations that I see here are 5, but if I go to the router where I am currently working, I see more. I see 4, then 8. I see about 9 translations. Total of 9. Now try to ping R2 from L1 loopback from S2. Okay, so let me just copy this IP address, this ping test, and let me work on switch 2. Let me work on switch 2 right now. Let's see. Will this work? What do you guys think? Yes. Second time it worked like a charm, but this time we're going to use the verbose still in R1. So let me just go to R1 and do the verbose command. I think it might not be supported. Type in translation. Yeah, the verbose command might be working only in real equipment because I tried and it doesn't seems to know that specific command verbose. So only in real equipment. We will see something like this with the specific timeout, the use, the date, the creation, the inside global, the inside local. That's pretty much that all the information that we can gather in a real life router. With the command is show IP NAT translations verbose. Let's go ahead and clear this. And let me go ahead and move on. Clear IP NAT translations. So let's go to R1 and let's work on it. So clear IP NAT translations, then asterisk. Let me just do it. Yeah, translation doesn't accept it. It's translation because it's packet tracer. And clear IP NAT statistics. Maybe this one only works in, yeah, statistics is not in packet tracer, it's only in real equipment. Maybe it's not supported, or depending on the version of the router that we have, it might not be supported. So let me go ahead and remove the NAT. We're going to remove the translation on R1, so let's work on it. Let me just copy and paste this command. Now, why are we getting this error? Because we have to access in config T, privilege mode. Now I paste it there and it works like a charm. And this time I'm going to use overload. Overload, let's work on it. Maybe I can do a test again from PCB. Let's go to PCB. Let me do a couple of tests. One, then a two tests. And I'm going to do the show IP NAT translations again in R1. Let's do a 2. So it will work. And there you have it. Amazing. You can see we have a total of 8 plus 8 is 4 plus 4 is actually 8. We have 8 translations. We have the different ports, the IP addresses. And you can see amazing, amazing. We have the inside local, the inside global, the outside local, the outside global, and all those translations working wonderfully. Wonderful, in a wonderful way. What else do we have? This is the translated IP address, of course, for the inside global. And that's pretty much everything we need to know. The answer may vary, yes. There is no dedicated translation between an inside or outside address listed. Let me run this command one more time. I think first we need to do a ping test from PCA. So let me work on it. And let me run that command again. Now, remember we have to do the 2 or exit completely. You have a total of 4 address translations here and the different sockets and ports. In the scenario right here, we only have 1. The verbose, we can add that command, but it will probably not work. We can still add it just to see the error. Even if we do the 2, it will give us an error because it's not supported by packet tracer. The only one is the show IP NAT translation. That's a command that is supported. Unique port number assignments. How do we keep track of the replies? Is with the unique ports numbers assignment. Path is the port address translation, and that's where we have different specific sockets or ports for each of the translations. Then we run the clear IP NAT translations again, just to cover our back there. Remember to do the 2 first, and there you. Let me go ahead and do it with the, like this. Let me just copy and paste it. It's actually translation, not translations. That's why it didn't work. NAT statistics, let's try that. Let me clear statistics. No, only the translation is accepted. Then we are removing the NAT overload. Here, we are doing all of these changes with config T in R1. Then we are adding this no command to remove the pool of NAT IP addresses. And then we are doing the NAT inside source list with the overload command. So let's work on it. Let me try the two IP NAT translation to see if we have any. Probably we will not have any because we just reset everything. Let me do an exit and paste it there. See, there is not any of those IP addresses. Now let's do a ping test so we can have some traffic there. We can finally have some traffic. Let's do it one more time. Great. Let's do it in the router. And you can see all of those translations. Now we are having the inside global IP address of 209.165.200.230. And we have the different ports there, which is representing that we are configuring at this moment port address translation. If we execute it from PC1 and PCB, let me just run it from PCB. Let me just run it from PCA. Let me just run it from the switch, one of the switches. Are we doing the same IP address? Yes. The other switch, great. So now let's run the two IP NAT translations, and you can see there is a bunch. There are so many translations there. Amazing, amazing. Verify the static NAT. You will verify the static NAT and breachability. Can we do a ping test for this IP address from PCA? Let's do a test here. Are we able to reach it or not? That's the big question. The first didn't go. The person didn't go. But maybe we are not doing it right. I think we might have to validate within the routers for that. In part 4, you will configure static NAT so that PCA is directly reachable from the internet. Part 4, you will be able to reach from R2 to this IP address. It's actually from R2, but if we check right now, let me see R2, we probably will not have, let's see if this works. We have the Cisco and class passwords there. Let's do a ping test. It's not working yet. We might have to configure some parameters there so it actually works. So let me go ahead and clear the translations. Let me go to R1 and paste it there. This is actually translation, not translation, and typing not translations. You can see there is nothing. There you go. Now we're going to add that source static IP address in R1. Config T. Let me paste it there. And there you go. Let me do a show IP not translation on R1. And remember, we have to do the do if we are in privilege mode. And you can see it there. Let's do an end. Let's do a Control Z, and let's run this command again. Show up in that translation. You can see it's translated the inside global IP address to an inside local IP address. Let's see if we can do a ping test from R2 to this specific IP address. Let's validate. Remember Control A here. We can do a ping test. And I'm wondering if we are doing it correctly. Yes, it worked perfectly, like a charm. Now let's do that show IP at translations there in R2. It's actually R1. Great, we got it. Thank you very much for following along. What else are we missing? I think we're pretty much done with the lab. You can see the ports there. You can see the specific sockets or ports that we have over here. All of those. And you can see the private IP address. We have the inside global, the inside local. Then you have the outside local, outside global. That's pretty much everything that we have there. Let me go ahead and clear the boards. Let's see if we are still missing something. I think we pretty much covered the lab. Yeah, we did it. Well, it's been a pleasure working on with you, boys and girls, today, completing this lab. Um, I think we have learned a lot from this lesson. It was a great experience and practice, and I will see you at the top of success. Remember, practice makes perfect. Until next lessons, take good care of yourselves, boys and girls, and goodbye.